We are given a list that should contain every number from 0 up to n, but exactly one of them is missing. In 0, 1, 3, 4, 5, the number 2 is gone. We want to find that missing number quickly without sorting and without extra lists. Here is a clean bit of math. If nothing were missing, the list would hold every number from 0 to n, and the sum of those is n times n plus 1 divided by 2. That is the sum we expect. We then add up the numbers actually present. The gap between the expected sum and the actual sum is exactly the value that went missing. No sorting, just arithmetic. Because one number is missing, the list length equals n, the top of the range. The expected total of 0 through n is n times n plus 1 over 2. We subtract the actual sum of the list from that expected total, and the difference is the missing number. Let's write the sum trick and find a few missing numbers. The list length is n, and the full range 0 through n sums to n times n plus 1 over 2. Subtract the actual sum from that expected total, and what's left is the missing number. Now let's test it and hit run. Two is missing from the first list, 3 from the second, and in the third, the missing value is 0 itself. The formula catches all of them. We compute the expected sum of the full range using the formula, add up what the list actually holds, and return the difference, which is the number that is missing. Summing the list is a single pass, so order n time, and we only keep a couple of running totals, so order one space. An exclusive OR approach has the same cost and avoids large sums. Use integer division in the formula so you stay with whole numbers. Note the list length equals n, the top of the range, since one value is missing. And in languages where large sums overflow, an exclusive of all indices and values sidesteps that problem.